project is Smart Irrigation System with data acquisition and real-time monitoring. The main aim of the project is to reduce water consumption and manual labor during irrigation and provide a simple and a cost-effective platform for users as well as researchers for future scope. Current systems in India do not acquire data for future analysis. This system will save data to a remote system which can be accessed anywhere in the world through internet connection. This data can also be used effectively with algorithms for a particular soil, climate, plant combination, which may in future reduce the need of constant data monitoring. The system will have a very simple based GUI, based interface at the client side.
So this is the block diagram of our whole system. The heart of the system is essentially the launch bar, which is the MSP EXP430G2. Now on the input side we have here two sensors. One is the temperature sensor, which is LM35, manufactured by Texas Instruments. The output is in the order of millivolts, so we need an amplifier to just amplify the output. The second sensor that we have here is the soil hygrometer or the soil moisture sensor. Now the microcontroller is connected to a power supply here, and the microcontroller is a very low power microcontroller which takes about only 3.3 volts to function. Now on the output side we see here the microcontroller is interfaced with a GPRS module, which is SIM900A, manufactured by Simcom. This GPRS module then communicates with the client side through a GUI. The client side is essentially a Chrome browser web app. Here the output of the microcontroller goes to this motor driving circuit, which is built using the L293D IC, which is again manufactured by Texas Instruments.
So this is the entire setup. This is the dry soil, this is the wet soil. This is the temperature sensor provided by TI, the LM35 sensor. This is the soil moisture sensor. This is the SIM900A module by Simcom, and this is the MSP430 G25F3 launchpad by TI. This is the motor which is connected to the motor driver circuit. The motor driver circuit is triggered by the launchpad using this wire.
So now after seeing the hardware, we come to the flow of data. Here, as you can see, this is a layout of the field which will be showing you in the live demonstration. Here in the center we have the on-field sensors, which are the temperature sensor and the soil moisture sensor. On the corner we have a server room, which is essentially the launch pad and the GPRS module. Now here we have divided the field into two parts. In one part we have some crops which represent the wet soil, and here where there are no crops we indicate the dry soil. So now basically after taking the inputs from the sensors, the data will go to the server room, which is essentially the launch pad and the SIM900, and from here after some calculations the motor will be switched on and the data will be simultaneously sent to the client side through a GUI. Now after seeing the hardware and the signal flow, we now come to the live demonstration of the project. Here is our temperature sensor and here is our moisture sensor. Now the moisture sensor, when I insert into a crop field, which is the wet soil, the inputs taken by the launchpad are now relayed to the client-side GUI, and now the launchpad decides that since the moisture and the temperature are at perfect value, the irrigation doesn't have to happen. Now I take the soil moisture sensor and put it into a perfectly dry soil. The launchpad will now compute the values and then it will switch on the motor as and when it is required. So now here, as we can see, the motor has been switched on and the water is flowing. Now after this, we'll just take a look at the client-side GUI.
So this is the GUI. The GUI is a Chrome web app or a Chrome extension. The reason we made a Chrome web app was because one, Chrome is a browser that works on all major platforms including Linux and Windows. Making a Chrome web app or essentially a web page is much easier than actually creating a native application. The code is easier to maintain and distribute. Uh, 3. We did not make a simple web page, but instead made a Chrome web application, because the Chrome, when you make a Chrome web app, Google allows us to use the Chrome Web API, which allows us, and one part of the API allows us to make direct raw TCP connection directly from the app, which is not possible if you create a simple web page. So I go ahead and launch it. Just reload it and launch. So this is the basic interface. Over here is the command window to send command directly from the GUI. Thus overriding the inbuilt functions in the MSP 430 G2553. I'll come back to this later. First, the data that we get from the MSP 430 G2553 is stored using a relay server into a database. That database is passed by this GUI. We have been taking data for the last 3 days, so from 10th of this month 2015 to 12th 03 2015. When I press submit, as you can see, all 3 days the temperature is in degrees Celsius and the moisture is in percentage. We have been taking readings at 2 times of the day, at 10:30 in the morning and 4:30 in the afternoon. You can even see the graph of this data, how this data changes. This is the temperature and this is the moisture graph. Now we come to the manual override. Consider I want to switch on the motor from the interface. So this thing will send it to the relay server, which is a simple Python TCP web server running on the same machine that this web app is running on. For example, I said send motor on and I press send. And the motor's on, I guess. Yes. And now I send motor off. Motor switches off.